Every country on the globe sees itself to be fully secured from any threat from other countries. For this reason, there has been rise in mergers and acquisitions of small organizations, the growing demand for robotic tanks and unmanned ground vehicles, the open system architecture for military land vehicles that provide optimal situational awareness and advanced combat abilities. Electronic camouflage technology advancements, and commercial off-the-shelf components such as software and hardware. The factors like rising military tensions, terrorism, and political instability, technological advancements, economic growth, and high demand for military equipment from different countries has made the military armored vehicles and tanks manufacturing market grow globally. The concept of a military tank was not particularly new in 1916. However, the ability to move troops safely through combat territories with a vehicle felt like an incredibly important innovation during the First World War. Tanks took advantage of combustion engines, armor plating, and a continuous track. They first entered warfare on September 15, 1916, at the Battle of the Somme. From there, the history of troop movements. The idea of safely bringing troops into the heat of battle had been present for hundreds of years. In China, chariots carrying as many as 4 spearmen were commonly used. In medieval Europe, the sides of siege engines were armored to protect the operator. During the late 1890s and early 1900s, mechanics experimented with ways to replace cavalry with some type of vehicle using an internal combustion engine. There were several variants of these armored cars created between the Boer War and the outbreak of World War I, but they were never used in France. They were too much like cars of the time and needed smooth roads to travel. It was not until the continuous track was combined with the internal combustion engine that a solution was reached. After the Second World War, the Americans focused on developing armored tanks which were faster, more nimble, and more powerfully equipped. During the 1950s, fear of a nuclear attack from Russia or another communist country gripped the United States. Many groups wanted tanks to be equipped with guided missiles and against tactical nuclear weapons. These concepts ultimately were too challenging and expensive. Designers focused on existing technology, upgrading armor, shell design, and movement capabilities. When the Gulf War began in the 1990s, tanks again saw heavy use, but the Iraqi forces were deploying incredibly out-of-date Chinese tanks. By the time the 2003 Iraq War began, however, Iraqi forces had upgraded to modified T-72s and had learned to hide or place them in dugouts, inflicting tremendous losses on British and U.S. troops. Eventually, the T-72s were outclassed by the M1 Abrams deployed by the United States, as well as other contemporary battle tanks. In many ways, tanks have been roughly the same for 70 years. It remains to be seen what the next dramatic development in tank technology will be. M1 Abrams battle tanks are the rock stars of military armor. They're made in only one place, Lima, Ohio. The Joint Systems Manufacturing Center in Lima is a government-owned site run by General Dynamics. Product manager Cliff Barber weaves past robotic arms, laser cutters, and cranes to reach a row of rusty orange hulks, some of the first Abrams tanks to be produced. They're waiting to be restored and upgraded at a cost of $6 million each. There are 800 workers at the plant, down from 1,253 years ago. Back then the plant rolled out 2 Abrams tanks a day. Now it's 1 every 2 days. This is the tank's full-up power pack, or FUP. It includes the Abrams engine, transmission, and all cooling apparatus, the oil coolers, and the exhaust. The turbine engine has 1,500 horsepower and is multi-fuel, meaning that it can work on many different kinds of fuel, from diesel to jet fuel to gasoline to kerosene, and even peanut oil. That gives the tank a great deal of flexibility, which is a major advantage during combat or other activity. The FUP is designed to be plug and play, meaning that if it is damaged or dysfunctional, it is pulled out in its entirety and replaced with a new one. On the battlefield, this is thought to be a more efficient way of repairing systems. In a case like this, the defective FUP will usually be taken away to a maintenance area. In combat zones, replacement FUPs are carried around by heavy trucks or possibly delivered by aircraft. The T-90 is a third-generation Russian tank designed by the Soviet Union to replace the T-72. It was seen by some as the equal to the M1 Abrams and the Leopard 2 at the end of the Cold War. Yet modern combat in the Russo-Ukrainian War suggests the T-90 is not the formidable beast it wanted to be. The T-90 Siemens main battle tank, MBT, is an advanced version of the T-series of Russian tanks, offering increased firepower, mobility, and protection. It entered service with the Russian Army in 1992. In February 2001, the Indian Army signed a contract for 310 T-90 Siemens tanks. 124 were completed in Russia, and the rest were delivered in knockdown form for final assembly in India. The Indian Ministry of Defense placed a $2.8 billion contract with the Ordnance Factory Board, OFB, to license build 464 additional T-90 Siemens tanks at its Heavy Vehicle Factory, HVF, Havati, for the Indian Army in November 2019. Self-protection of T-90 Siemens. The T-90 tank is protected by both conventional armor plating and ERA. It is fitted with the Shtora 1 Defensive Aids Suite, which is produced by Elektroenergo of Russia. This system includes an infrared jammer, laser warning system with 4 laser warning receivers, grenade discharging system that produces an aerosol screen, and computerized control system. It is also fitted with nuclear, biological, and chemical (NBC) protection equipment. Fire control and observation. The T-90 Siemens uses the 1A4GT Integrated Fire Control System, IFCs, which is automatic but features a manual override for the commander. The IFCs contains the gunner's 1A43-day fire control system, gunners to 1 Co-1 thermal imaging sight with a target identification range of 1.2 kilometers to 1.5 kilometers, and commander's PNKS sight. A 1G46-day sight/rangefinder with missile guidance channel, 2E42-4 armament stabilizer, 1V528 ballistic computer, and DVBS wind gauge comprised a gunner's 1A43-day FCS. A 10-4 Siemens AGAT-S day/night sight, which has identification ranges of 800 meters day and 700 meters night, are included in the commander's PNK-4 Siemens sight. The driver is equipped with a TVN-5 infrared night viewer. The T-90 Siemens has a liquid-cooled V84 M618 kW, 840 HP, 4-stroke V12 piston engine. This engine can be fueled by T2 or TS1 kerosene and A72 benzene, in addition to diesel. The tank can carry up to 1/600 L of fuel in the main fuel tanks and fuel drums. The fuel tanks are reinforced with armor plating. The tank is fitted with a snorkel for deep fording and can ford 5 meters of water when prepared with equipment, which can be deployed in 20 minutes. Primary reduction gear, 2 planetary final gearboxes, and 2 planetary final drives are included in the mechanical transmission. The running gear features torsion bar suspension with hydraulic shock absorbers at 1, 2, and 6 road wheel stations, as well as tracks with rubber metallic pin hinges. The main armament of the T-90MBD consists of one 125mm to a 46mm smoothbore gun, which fires conventional natures of separate loading ammunition, projectile and charge, including HE-frag, high explosive fragmentation, and a PFS-DST, armor-piercing and stabilized discarding salvo, tracer. It can also fire a 9M 119M laser-guided anti-tank projectile fitted with a tandem heat, high explosive anti-tank warhead out to a maximum range of 5,000 meters. The T-90A uses an automatic loading system with 22 rounds ready to fire that provides a high rate of fire, up to 7 rounds per minute. The 7.62mm 6B7T machine gun is mounted coaxially, with the main armament and a remote weapon station. UDPD-5BV-1 is mounted on the turret roof, armed with one 12.7mm NSVD heavy machine gun. This remote weapon station can be laid and fired from within the turret. Mounted on either side of the turret is a bank of 6 electrically operated 81mm smoke grenade launchers, which are in a new low-angle configuration compared to those fitted to earlier Russian MBDs.